Okay, I want to set up some of these systems of equations in 3 variables and set them up so that we can solve them using matrices. Okay, here's our first one right here. Remember, this is our goal for these matrices. We want to put this in the form of a matrix, and then we want to get zeros here, here, and here. We use those elementary row operations. But the first thing we have to do is write this as an augmented matrix and do it correctly. So let's see. If I write this as an augmented matrix, I'm just going to take the coefficients and the constant terms right across that row. So 1, 1, 1, 4. And I like to draw this little line down here like this that just tells me I'm separating the coefficients from the constant term. 1, negative 1, 2, 1. So 1, negative 1, 2, 1. Okay, didn't leave myself enough room here. And then 1, negative 1, negative 1, 5. So 1, negative 1, negative 1, 5. So when I do that step, I'm not thinking about this at all. All I'm doing is taking this and translating it into a matrix. Once I have the matrix, now I look over here to my goal and I start thinking about that, and I'm thinking about getting a 0 here and a 0 here. I like to get these two here first, then that one third. Then everything's okay. So when you look at this, you say, okay, how can I get a 0 in this position using my elementary row operations? Well, if I multiply this row by negative 1 and add it to this row, I've got it. So negative 1 times row 1 added to row 2, and then that replaces row 2, we'll be in good shape. So I'll just start that for you. So I'm not changing row 1 at all. 1, 1, 1, 4. Row 2 now is going to be negative 1 times this plus this. So negative 1 times this added to this. Negative 1 times 1 is negative 1 plus 1, 0. That's why we did it. Negative 1 times 1 is negative 1 plus negative 1, negative 2. Negative 1 times 1 is negative 1 plus 2 is going to be 1. And then negative 1 times 4 is negative 4 plus 1, negative 3. Okay, and now I've got to work out this row right here doing something similar, but it looks like I'll just do the same thing with row 3, and I'll have both zeros right here. So there's a start on that problem. How about this problem right here? First thing I want to do is write it as an augmented matrix. Okay, it's a system of 3 equations in 3 variables. Let's go across the top with the coefficients of x, y, and z and the constant term. Coefficient of x is 1. Coefficient of y is 2. Coefficient of z is, that's right, 0. And then the constant term is 3. Now I go to this row right here. The coefficient of x is, that's right, 0. That's nice. I want that 0 right there, right? Coefficient of y is 1. Coefficient of z is 1. And the constant term is 3. Last row I have 4x, so that's a 4. Coefficient of y is, that's right, 0. And the coefficient of z is negative 1. And there I have a 2. Okay, so here's my goal. I want zeros in these 3 positions, starting here, then here, then here. Okay, looks like I've got it right there, so I need to get a 0 in that position. What's going to happen? Well, let's see. How about negative 4 times row 1 added to row 3 becomes row 3. And when I do that, negative 4 times 1 is negative 4 plus 4. That'll be 0 down there. Now, that might change from a 0. It's a 0 right now, and you think that's okay. That may change when you go through and multiply this by a constant and add it to this, but that's okay. As long as you have these 2 zeros right here, getting a 0 back in that position will be easy. Okay, so that's how you set up some systems of equations, 3 equations in 3 variables. First step is this right here. Write it as an augmented matrix. Is there more than one way to proceed after that? You bet there is. There's all kinds of different ways to proceed. You'll see that you'll do some of these problems one way, your friends might do it another way. As long as you consistently stick to those 3 elementary row operations, you can't go wrong. If you get these zeros in this position right here, you will eventually end up with a system of equations equivalent to your original system, but a lot easier to solve.